let's get started. All right, everybody, welcome. It's really nice to see you all on this Thursday evening. I'm sorry I didn't. Zoom user is Ippeling. So hang on a second, Nelly. It's Ippeling.
Yeah. All right.
Here we go. All right. Sure, is it just the 5 of us?
Yeah, it's not that way.
Oh, wow. Okay, anyway, let's get started. So tonight's lesson, we're going to talk about trig basics. And when I, absolutely, can you see there? So when I decided to do this lesson, when I mean trig basics, I mean, not all of these questions are 100% straightforward and simple, but this is the first question in trig. So in other words, I'm not looking at the graphs, I'm not looking at the 3D trig, we're just looking at the very first question in trig that you would get, all right? And I think it's really important for us to be able to do well in at least part of this, because we can't get all the marks that we want and we need simply from analytical geometry and from the statistics. So if we want to do well in our maths exam, we are forced to either engage with Euclidean geometry or we're forced to engage with trigonometry. So, you know, trigonometry is seen as easier than Euclidean geometry. So that's why, you know, teachers try and sort of push this section quite a lot. All right. And something that you can do that will really help you is if you've made sure that you've learned all your grade 11 trig. So learn all your reduction formulae, in which quadrants, your cast diagram, etc., etc. And that just means that your life is going to be so much easier when you now start working in this particular section. So here we're looking at the sorts of questions where they would ask us to simplify to a single trigonometric term, or they could ask us to work with Pythagoras and work on the Cartesian plane, or they could give us a ratio in terms of a letter. There's lots and lots of different things that they could ask us to do. All right, so in this particular question, we've been told, this is now 5.1, that cos theta equals -2 over root 13, where theta is an angle between 180 and 360. So they want us to determine the value of the following without the use of a calculator. So it's very important that we do not ignore instructions and that we do exactly what it says. So when they say without the use of a calculator, they mean that you're not just going to pick up the calculator and work out the value of something. The other thing that's important about this question over here is that the value of theta is completely unimportant. Okay, you are not calculating the size of theta, right? Which you would only be able to do with the aid of a calculator. So they do not want the size of theta. The size of theta in this situation here is completely irrelevant to the question. Okay, so when we have a look at the first thing that they want us to do, we see that they've given us the sine of 90 minus theta. And this is why it's so important that we learn our grade 11 trig, because we need to know how to reduce that. So what is sine 90 minus theta reduced to? It reduces to cos theta. Okay, and thus our answer would be the same as what we were given. We would end up with -2 over root 13. Absolutely. Okay, so 2 marks there, 1 for the cos theta, and then 1 for the answer. Okay, lovely. Next one that they want us to have a look at is cos 2 theta. So now what are they expecting us to do? They're expecting us to be able to use one of the formulae from our sheet. So either we can do this, or this, or this. Okay, it does not matter in the terms of this particular question which one we use. Okay, it does matter when we start working with identities and with general solutions, but for this, where we're working on the Cartesian plane, it really doesn't matter. So you can just pick one and go for it. Okay, in fact, in this case here, we don't even need Pythagoras to be able to answer these questions. Okay, so here we can write this as 2 cos squared theta minus 1. And now we can go ahead and go and sub in. Sorry, I should have actually probably set that out over here. It's a little bit better. Hold on a second. So we would have written cos 2 theta as 2 cos squared theta minus 1. And now we're going to go and sub in what cos theta is equal to. So in this case, negative 2 over root 13. They want us to square this. And then we need to subtract 1 from it. Okay, so that would leave us with 2 times 4 over 13 minus 1. Okay, so that would be 8 over 13 minus 13 over 13, which is where we would get the negative 5 over 13 from. Okay, number 3 is easy. Okay, let's have a look. So without using a calculator, determine the value of. Yeah, that is an easy question. So if we look at 5.2, they really have not challenged us too much here. They've been lucky, well, we're lucky. They've given us something that's fairly straightforward. So if we have a look at what they've given us, what does it look like? This thing over here, what do we call this thing? Exactly. All right, quite right, Kanisile. So we would look at the formula sheet and we can see that they have given us a cosine compound angle. There's only one thing that they've done differently. What is it that we would still need to do? So our next step here, we would need to swap the terms around. Okay, so remember every term owns the sign in front of it. So we would have written the second term as negative cos 27 cos 33 plus sine 27 sine 33. Okay, now if we go and have a look at our formula sheet, right, we do not have a negative in front. Look there, we don't have a negative there, and we don't have a negative there either. So this means we need to factorize. Okay, so we're going to take that negative out. And we're going to end up changing the sign of the first term and changing the sign of the second term. All right, now what's inside the brackets looks exactly like what we have on our formula sheet. All right, so this means that we are now ready to do the reversal of the expansion. So that means that we can then write this as minus cos, and cosine does not keep its sign. So inside the brackets here, it would be 27 plus 33. All right, and that would give us negative cos 60. And we know that that is a special angle. All right, so we would write that as minus 1 over 2. Okay, so yeah, nice easy question there. All we had to do was factorize and then use our formula sheet for the cosine compound angle. Okay, let's have a look at the next question if we're all okay. They want us to show that. So now here there's a lot going on. Cos 90 minus x times cos y minus cos 180 minus x times sine minus y all over cos x cos y minus 360 minus sine 540 plus x times sine y. And that's got to equal the tan of x minus y. All right, so a lot going on there for us to go and sort out. This is where knowing our grade 11 work is so important, because all of our reduction formulae would be, if we know our reduction formulae, we can answer this particular question. Okay, so I'm just going to create a little bit more space down at the bottom. Okay, so we have got cos 90 minus x. What would that reduce to? What would cos 90 minus x reduce to? Okay, so sine x or sine theta, quite right. So that would become sine x. And cos y, that obviously wouldn't change. We would just leave that as cos y. Now we've got our minus, and on the other side, we've got cos 180 minus x. What's that going to reduce to? Quite right, negative cos x. Lovely. Times, and sine minus y, what is that going to reduce to? Minus sine y, correct. Okay, good stuff, everybody. Let's do the denominator now. Okay, so cos x is obviously not going to be anything other than cos x. Okay, now cos y minus 360, what is that going to reduce to? Add 360, absolutely, and that just gives us cos y, 100%. Cool beans. All right, the next bit minus, now sine 540 plus x. So what could we do to the 540? Okay, so we can subtract 360, that's fine, not a problem. When we do that, we end up with 180 plus x. So that means that this is going to reduce to negative sine x because 180 plus x is quadrant number 3. Okay, multiplied by sine y. Okay, there we go, we're getting there. Okay, so now we've got some clearing up to do with regards to terms. So at the top, we have sine x cos y, and then a negative times a negative times a negative is going to leave us with a negative. Cos x sine y. Okay, and at the bottom, we're going to end up with cos x cos y. A negative times a negative is a positive. And then here we've got sine x sine y. And again, we are looking at our formula sheet. Okay, I'm just going to go and grab that and bring it down here for us. There it is. Oopsie, let me just move it over. Okay, and again, there's just this little error on the sheet. I don't know how that got into a national paper, but anyway, these are the things that happen. And if we compare our numerator to our compound angles and our denominator to our compound angles, we can clearly see that we're working with compound angles here. So sine x cos y minus cos x sine y is a sine compound angle, and sine keeps its sign. So this means that we would end up with sine x minus y, like so. And at the bottom, we can see that we've got another compound angle. We've got a cosine compounded angle. So here we're going to end up with cos x minus y as well. Right, yes, that's it. And of course, sine x minus y over cos x minus y is going to leave us with, let me just move this one out the way. It's going to leave us with tan x minus y. All right, and now we have proved that the left-hand side equals the right-hand side. Okay, there we go. All right, so 5 marks there. That wasn't too bad. Left-hand side equals right-hand side, quite right. Okay, so the next thing they want us to do is a ratio in terms of a letter. So they've told us the tan of 42 equals 1 over m. They want us to express the following in terms of m. So the first thing that they give us is the cos of 222 degrees. Okay, so we've got to figure out where that comes from. We've got to apply a reduction formula. But the other thing that we have to do when working with ratio in terms of a letter is we're also supposed to draw a diagram, and we're supposed to use the theorem of Pythagoras to work out anything that is missing. All right, so in other words here, what we would do is we would interpret the tan of 42 degrees is interpreted as y over x. So if it's equal to 1 over m, what they're saying is that y is 1 and x is m for this particular question. So what's missing is the value of r. So we would say x squared plus y squared equals r squared. Okay, so 1 plus m squared is r squared. Okay, which means that r is going to be equal to root 1 plus m squared. There we go. All right, and now that we know what r is, we can go ahead and we can answer our question. Of course, we need to know what r is if we're working with cos, because cos is x over r. So now back to grade 11, apply our reduction formulae. We know that we can write this as the cos of 180 plus 42. This step is not necessary to show, but it just explains to you where it's coming from. This next step is important. We've always got to show what we get when we use reduction formulae. So that would be negative cos 42. And thank goodness we went and worked out what r was in terms of m. This would give us negative m over root 1 plus m squared. Okay. All right, is that making sense? Yes, can you see? Go for it.
Ma'am.
Maybe you can just turn your mic up a little bit. Can you see? You're very soft.
Can you hear me now?
I can hear. Oh, sorry, I'm turning mine up as well. Yes, I can hear you now.
Okay. Ma'am, for question 5.4.1, ma'am, if I had to say like cos 360 minus 138 is equals to 222. Would it be correct? And then after that, I say 180 minus 42 is equals to 138, making it cos 42. Will that be correct?
Are you talking about question 5.4?
Yes, ma'am. 5.4.1. Okay. If I had to say, yes, ma'am.
Yeah, so what you're saying is absolutely fine, can you see? It's just that it's taking you a lot longer to get to that negative cos 42 than if you just used a straightforward reduction formula like 180 plus or 180 minus. Now, the idea is that what you want to do is you want to work out which quadrant you're in. So if you know, for example, so here if we are, so let me just draw a Cartesian plane. Okay, so you know that that's 0, you know that that's 90, you know that that's 180, you know that that's 270, and you know when you get back here, you've got back to 360. So if we're talking about an angle that is 222 degrees, we know that it's got to be in the third quadrant, and that's why we would use the reduction formula 180 plus. So if they gave you an angle, can you see there, of 137, then you now know you are in quadrant number 2, you would use 180 minus. Okay, so technically speaking, you shouldn't actually be using 360 minus because it's not in the fourth quadrant. This is the third quadrant. Okay, but you can do it that way. It's just going to end up being a lot longer. So here, if you had an angle like 291, you know that that is in the fourth quadrant, and then you would use 360 minus. Okay, that's what you're supposed to be doing. Okay, no problem. Okay, so where were we? We got as far as the cos of 222. Okay, so now let's do the sine of 84. The sine of 84. So, excuse me, I beg your pardon. If we look at 42 and we look at 84, we straight away notice what? What do you see when you look at 42 and 84?
Double.
Double, exactly. So 84 is double 42. So that means that we can now write the sine of 84 as the sine of 2 times, sorry guys, 2 times 42. Okay, and now using our formula sheet, so our double angle, so in other words, this over here, we can write this as 2 sine 42 cos 42. Sorry, that's really, really squashed up. Let me make some space over here on the left-hand side and just write that a bit better. That is very, very squashed. Okay, so we have the sine of 84, which we know is double 42. And then using our double angle sine formula, we can write this as 2 sine 42 cos 42. All right, and now we are ready to go and substitute in. Okay, so to the sine of 42 is y over r. So this would be 1 over root 1 plus m squared. So 1 over root 1 plus m squared. This is going to be a bit of a nasty fraction to work with. And then the cos of 42 is x over r. So that's going to be m over root 1 plus m squared. Okay, and now we have to go and multiply these two together. I just want to get rid of this. No, it was part of the same question. It doesn't matter now. Okay. So when we multiply numbers and fractions, we have to multiply the numerators together and the denominators to get this. Remember, this 2 is in the numerator. So it's going to be 2 times 1 times m, which is going to leave us with 2m. And when we multiply anything by itself, it's going to be that thing squared. So it's just going to be 1 plus m squared as our answer. Okay, does that make sense, everybody? How are you guys feeling? Is this making sense? Are you happy? Cool. Good, I'm glad. All right, so there's a couple of thumbs ups. Thank you, Isona, and somebody else put a thumbs up as well. Okay, good stuff. Glad we're all okay. So now that that's done, we can move on to the next question, 5.5. So here it says, if sine theta equals cos theta plus p, and sine theta equals minus cos theta plus q, determine the value of cos 2 theta in terms of p and q. So again, what I'm going to do is I'm going to copy that, and I think we can always come back up to this question. I'm just going to stick it over here so that we can just look at a clean screen instead of stuff that's got writing all over it. Okay, so now with this particular question, this is obviously a little bit harder, right? So we need to really sort of put on our thinking caps and become quite creative in terms of a solution. What do you think you should do here? I mean, they've said to us they want cos 2 theta in terms of p and q. So if they want things in terms of p and q, what they want us to do is make p and q the subject of the formulae. So as far as the equation on the left-hand side is concerned, we would end up with sine theta minus cos theta equals p. And on the right-hand side, we would end up with sine theta plus cos theta equals q. What would we do with this now? I mean, if you think about it, we have 4 operations in maths. So we can add, we can subtract, we can multiply, and we can divide. Those are the only things, the only operations that we've got. So now in terms of operations, what do we need to do? I mean, if we added these together, could we get cos 2 theta? No, because that's going to give us 2 sine theta. If we subtract them, same story. What would happen if we multiplied them together? So in other words, if we worked out the value of PQ. So PQ would be sine theta minus cos theta times sine theta plus cos theta. So this would give us difference of 2 squares, wouldn't it? We would end up with sine squared theta minus cos squared theta. And so we are becoming closer and closer to our answer. If we go back and just grab our formula sheet, I just want to show you something. Oh, oopsie. Let me just stick it in the middle there. Okay. So if we have a look here, we can see that cos 2 theta, which is what our question is asking us for, is cos squared theta minus sine squared theta. Here we've got sine squared theta minus cos squared theta. So what we're allowed to do here is we can factorize. So I'm just going to rub that out and then just write it a little bit closer to the top. So this gives us sine squared theta minus cos squared theta. So just like we factorized out the negative, where did we do it? Did we do it anywhere up here? It was just, no, we didn't. Okay, so we can factorize out the negative, and that will make this sine squared theta plus, oh, sorry, hang on a second, sorry, my mistake. Let's do it like this rather. Okay, so sine is going to change its sign and cos is going to change its sign. So this is going to end up being positive cos squared theta minus sine squared theta. And there we have our negative 2 cos. Sorry, guys. We have negative cos 2 theta. Okay, so what we've managed to calculate is that P times Q equals negative cos 2 theta. Right, so what we've been able to calculate is that PQ equals negative cos 2 theta. Remember, we wanted to solve for cos 2 theta, so dividing both sides by -1, we would then end up with cos 2 theta is equal to negative PQ, like so. Okay, and that's how we would do that question. How are you all feeling? Does that make sense? Any questions? At ease, good. Any questions? You want to try another one like that? Let me see what I have up here, Itumeleng. Is there something else? I know the perfect question. I just don't know where it is right now. Oratile, I tell you what, if you give me just 2 seconds, I can go and have a look. Where is it? Hang on a second. Okay, hang on. I think I can find one more. Just give me 1 minute. I want to just go up here. Just give me a second, guys. See if I can find something that is similar. I think it's this one. Yeah. Ha ha. Okay. I found the question that I wanted. Okay, I'm just going to snip it out. There we go. Okay. So that is another question from a past paper that you will not have seen before. Okay, so in this situation here, it is given that f equals cos alpha plus sine alpha, and g equals cos alpha minus sine alpha. Determine the value of tan alpha in terms of f and g. Can Nelly and I give you guys a couple of minutes and you can tell us what you think? Just think that one through. Okay, so any ideas? Yeah, this is a difficult one, can you see that? But I mean, again, remember your options are your four operations. You can either add, subtract, multiply, divide. Okay, obviously you can square and square root and stuff like that, but, not in this particular case. First of all, tan alpha, all right, what is tan alpha equal to? Think identities. So tan alpha would be exactly. Okay, so it would be sine alpha over cos alpha. Quite right. Okay, so that gives us maybe at least a starting point. We need to be able to write an expression for sine alpha and cos alpha, because if we can put the one over the other, then we've got an expression for tan alpha. So that gives us an idea of where to go with this. Okay. Let's just try a couple of options here. If we multiply f and g together, does that help us? Well, look at what we get. We end up with cos alpha plus sine alpha, and here cos alpha minus sine alpha. And if we removed our brackets, we'd end up with cos squared alpha minus sine squared alpha. So that doesn't really help us in this situation. Okay, so multiplying them together is fine, but it doesn't help. Okay, so let's scrap that. Multiplying didn't work. Okay, let's try adding and subtracting. What would happen if we add f and g together? We'd end up with cos alpha plus sine alpha plus cos alpha minus sine alpha. So this gives us 2 cos alpha. Well, at least we don't have a square. Okay, well, if we can get rid of the 2, then at least we've got something similar to what's going on the right-hand side over here. Well, what would happen if we said f minus g? We'd end up with cos alpha plus sine alpha minus cos alpha plus sine alpha. I've just gone and changed the signs there. Okay, so now we end up with 2 sine alpha. And if we take 2 cos alpha and we put it over 2 sine alpha, 2's can obviously cancel. Sorry guys, wrong way around. Beg your pardon. If we take 2 sine alpha and we put that over 2 cos alpha, we could do that, and we would end up with tan alpha. Okay, so tan alpha has to be equal to f minus g over f plus g. Does that make sense? Yeah. Mind blown. Hey, Mr. Bavuma. I can go through it again. That's fine. No problem, Boyd Sheppel. I'm quite happy to go through it. Okay, so like I've always said to you guys, I like doing a little bit of problem solving with you. So, you know, it is nice to be able to look at these sort of more difficult questions. Okay, so Oratile, this is the sort of thing that is really, it's very creative in terms of your solution. You really kind of have to think out of the box, and don't feel bad or beat yourself up about it to order these questions. Gugu, I have got a whole page of extension questions on this sort of stuff that I regularly give to my matrix. So, you know, maybe what I can do, yeah, 100% Kanyesile. Yeah, don't be afraid to play around with stuff. That's why you got to go and do everything that you know how to do first. And then, you know, you can play around with the ones that are then left over. Okay, once you know that you've got all the marks you can possibly get. So it's difficult for me to teach you how to think like this, but yes, you've basically got to be willing to experiment a little bit. And if something goes wrong or it doesn't work out the way that you expected it to, is to say, okay, well, I've tried this didn't work. What else can I try? What other options do I have? Okay, so remember, we've only got the 4 operations. Okay, obviously apart from squaring and cubing, all that kind of stuff, but we can only add, subtract, multiply, and divide. There's not anything else that we can really. I can share them with you. I can. Isona and Kanisile, what I will do is I will send the worksheet that I've got, because I've actually got something else. It's like a checklist for you guys before boot camp. I will send it to Christine, and then she can email all of this to you. Okay, and then we can have a look at some of those questions. Can you see, Leah? Not really. I mean, obviously the thing is that you've got to practice good maths every step of the way. You know what I mean? So, you know, you can only add like terms. You know, you can't rip a negative off something. You have to factorize. You know, as long as you're still doing good maths, it's fine. Okay. So yeah, we had decided that what they wanted from us, which was tan alpha could be written as sine alpha over cos alpha. So that's really what we want. We want to try and get an expression for sine alpha in terms of f and g. All right, so we saw when we multiplied the two together, we ended up with squares. We have no squares in our answers. Good maths would play around 100%. You've got it. So that's why we say, okay, well, oh, lovely, Mr. Bavuma. I'm so glad. I'm so glad. Absolutely. It's just completely just out of the box. You know what I mean? And not being afraid to experiment, you know, and just say, well, I've tried something and this didn't work. So what else can I possibly do with this question? So what we find is that if we add expressions f and g together, we end up with 2 cos alpha. Okay, because cos alpha plus cos alpha is 2 cos alpha. That at least gives us part of the story here, okay, because at least we've got this bit. Okay, I know we've got a 2 in the front, but we can do something about that. When we minus the expressions from one another, we end up with 2 sine alpha. Okay, so now we're starting to get somewhere because we know we want to put sine alpha over cos alpha to get tan alpha. Okay, so that's sort of like your starting point. Okay, and once you've put f minus g over f plus g, you've then got, and cancelled out your 2's, you've now got tan alpha in terms of f and g. Okay. Yeah, nice question. So yeah, the other one was fairly similar to this, but yeah, I'll find that sheet and I'll get Christine to send it to you guys, and then you can have some fun playing around with these sorts of questions as well. Okay. All right, well, we've still got a little bit of time left, so we can go back and have a look at, do you want to do a general solution? I mean, is there sort of something that grabs your fancy here? You want me to just work through from top to bottom? I mean, it's another ratio in terms of a letter, which you guys have already done. Okay, well, let's do it then, Mr. Bavuma. Right, I like this too. I think that it's a little bit of a challenging question as well, which I think is quite nice. Okay, let's have a look. So we're going to do 5.3.1. I'm going to just shift this up so that we've got that over there. All right, so what they have given us in 5.3.1 is this rather nasty looking thing. So sine 2x plus 2 sine squared. And what's unusual here is that we've got this 45 minus x, and it has to be equal to 1. So essentially, this is what we've got on our left-hand side. Okay, so now again, in order to get to a solution, we need to be creative. So what do we want to do here? We can use compound angles if we want, which is that 45 minus x. If you want to do it that way. The identity question. Okay, cool. Because obviously 45 minus x is a compound angle, isn't it? So we could use compound angles here if we wanted. Let's just try it and see what happens. So we're going to end up with sine 2x, which we know is 2 sine x cos x. And then here plus 2. And then I'm going to use my compound angle expansion. So I'm going to write this as sine 45 cos x minus cos 45 sine x. And that has to be squared, okay, because of my square over here. All right. I've got some special angles that I can work with here. So I'm going to use those first. So I'm going to write 2 sine x cos x plus 2 times the sine of 45 is root 2 over 2, isn't it? And as is the cos of 45. So I've got root 2 over 2 cos x minus root 2 over 2 sine x, which now has to be squared. What I can do here is I can factorize out the root 2 over 2. So I've got 2 sine x cos x plus, keep my 2 there, and now I'm going to factorize inside these brackets, and I'm going to take out the root 2 over 2, the highest common factor, and then here I've got cos x minus sine x, and this still needs to be squared. Okay, so now when we square it, we're going to end up with 2 sine x cos x plus so that would be squared. So that would give us what? 1 over 2. So plus 2 times, and that would be 1 over 2 over here. And then here we would have ended up with cos squared x minus 2 sine x cos x plus sine squared x, essentially. Okay, does that make sense to everybody? So I've squared the fraction and I have squared the bracket. Are we all still okay here? And now I can remove my brackets. 2 times a half is 1. So essentially what we've got, guys, is 2 sine x cos x plus cos squared x minus 2 sine x cos x plus sine squared x. So this one over here and this one over here are like terms. And sine squared x plus cos squared x is equal to 1. There we go. Okay, so Mr. Bavuma, you're saying, wait, what happens if you multiply root 2 over 2 with a 2? Okay, so now there you would be breaking maths if you did that. Okay, because remember that root 2 over 2 is inside the bracket and it has to be squared first. So order of operations dictate that we first have to do exponents and then we multiply. Okay, that's all right. That's all right. At least you're thinking, you know, and you're asking questions, which I think is brilliant. So essentially what we've got is if we've got, so look at it like this. If I've got A multiplied by B and I square it, then it's going to give me A squared B squared. Okay, so in the same way, I'm going to square this and I'm going to square the bracket. Okay, that's what it means. That's okay, Mr. Bavuma. Don't apologize. That's why we're all here. Okay, no judgment. All right. Is that making sense to everybody? Yeah, all the best for your exam tomorrow. What are you writing? Oh, wow. Okay. Sure. So your hand is going to be sore after all of that writing, isn't it? My daughter also did drama. So lots and lots and lots of writing. Oh, well, all the very best for tomorrow, Mr. Pavuma. We'll be holding thumbs and toes and everything else. Essays after essays, it is, isn't it? Yeah. It does, Orotile. Yeah. So it's like with everything, you know, when you first start doing it, it's difficult and confusing. And then the more you do it, the easier it becomes. It's just time. Time is always against us, isn't it? You know, because you guys have got not just maths to worry about, but other things too. Good. I'm glad you understand the identity. Thanks for picking that question. Let's see if we can do 5.3.2, and then I think we'll have to call it a day there. I don't think we're going to have time for anything else. In fact, I think even that's going to be a little bit of a squash, but let's just try and do it. Okay. So they've said, using our result, determine the value of sine squared 15. Using our result, the value of sine squared 15. Okay, so sine squared 15, and again, this is where our grade 11 stuff helps us so much. Sine squared 15 is sine squared 45 minus 30. Okay, because those are special angles, aren't they? So what we could say is we can let x that's what we've got, 45 minus 30. Okay. And then, okay, because now here, see, what we've got is the 45 and the 45 and the minus, and there's the x. So in other words, what we're doing in the situation is we're letting x be equal to 30. Okay, so again, this is really out the box. So we're letting x be equal to 30 degrees in this particular case. So what that means for us is that sine 2x plus 2 sine squared 45 minus, sorry, x, not 1. Minus x equals 1. So now let's go and sub in our 30. Sorry, guys, we're kind of running out of space here. So this would give us sine 2 times 30 plus 2 sine squared 45 minus 30, which has to be equal to 1. Sorry, oh, I'm running out of space. Let me just see if I can move this over. It has to be equal to 1. So now this gives us sine 60 plus 2 sine squared 15 equals 1. And so 2 sine squared 15 would be equal to 1 minus the sine of 60. Remember, the sine of 60 is a special angle. So that would be root 3 over 2. And then we would need to divide by 2 to make sine squared 15 the subject to the formula. Okay, so that means that we would now end up with 1 over 2 minus root 3 over 2. Is that correct? Which means we would end up with hang on a second. If you've got root 3 over 2 and you divide it by 2, that's the same as taking root 3 over 2 and multiplying it by 1 over 2. Okay, so then you're going to end up with root 3 over 4. Sorry, so it's root 3 over 4 times by 2 times by 2, and then that's going to give us 2 minus root 3 over 4, and there's our answer. Okay.